For this lesson, we'll look at graphing radicals, the roots of math. And the reason we have that subtitle is because radicals in math means the roots. And we'll look at square roots and cubic roots for today. We'll first look at the parent function f of x equals square root of x. And one thing to remember with this is we are graphing on two real planes. So both our x and y are in the real number lines. So we need a real number to get out of it. And if you remember the quadratic formulas, if we have a negative number, we have an imaginary number. So what I need to do is find the smallest possible number I can get without having a negative. And in this case is the square root of 0. And because we just have x, when x equals 0, we'll have the square root of 0, which equals 0. This means that the domain will be x is greater than or equal to 0, and the range is y is greater than or equal to 0. And then when we come to look at the graph, we'll see that it starts at 0, 0 as I zoom in, and it continues to move up. And so I can look at where it hits 10. We have to go all the way to x equals 100. We see that it slows down quite a bit, but it will continue to go up. First transformation we'll look at is changing the domain. And here we have the square root of x minus h. Well, h will move the graph either left or right. And this should be very similar to the quadratic and rational functions we just learned. We also have the cube root x minus h, and it will have the same effect. If we look at the root of x plus 5, we'll move the graph left 5 spaces, and we can also see that our domain is going to change. So what number can we plug in to get a 0? And in this case, this is minus 5. So we have root 0 equals 0. So a domain would be x is greater than or equal to negative 5. For the minus 2, we'll have the same effect. It'll move to the right 2, and so 2 minus 2 will be 0, and that will give me the domain is x is greater than or equal to 2. And so you can see why it would move left and right. If we look at the graphs, the root x plus 5 moves the graph left 5 spaces, and we saw that with the domain we just looked at. And the root x minus 2 will move the graph right 2 spaces, and we saw that when we found the domain. The next transformation we'll look at is changing the range, and this will move it up and down. So we have the root x plus k, where k will move up the graph either up or down. Again, extremely similar to the rationals we just looked at. If we have the cube root of x plus k, we'll have the same effect. So we look at x plus 9, it will move the graph up by 9 spaces. And again, we look at what the smallest square root we can. In this case, x can be 0, and so we'll have 0 plus 9, giving me a range of, so my domain will still be x is greater than or equal to 0, but my range in this case will be y is greater than or equal to 9. Same with minus 4. We can plug in a 0 as the smallest number we can with the square root, giving me 0 minus 4, which is 4. And so my domain in this one is x is greater than or equal to 0. And our range is y is greater than or equal to negative 4. Forgot that negative on that one for the answer. Looking at the graphs, we expect the x plus 9 to move it up, which our yellow one did move it up by 9, and we saw that with the range. And our x minus 4 to move it down by 4. And again, we see that. Notice I'm continuing to judge everything off of the parent function. For our last slide, we'll look at two of these moving left and right at the same time. And so we have the square root of x plus 4 under the square root minus 5. And this will move the graph left 4 and up by 5. And we can see this just plugging in. We ask ourselves what plus 4 would equal 0, and we get negative 4. We ask ourselves what plus 4 would equal 0, and we get negative 4. And then we subtract 5. I'm going to add parentheses there. So we get the root of 0. Now notice, every time I'm always looking for the root of 0. So whatever gives me the root of 0, which will be 0 minus 5, which will give me negative 5. when I look at the graph here, look at this, we move it down by 5 and 4 to the left, which is what we predicted.